tomorrow. I don't know. All right, so let me give you, in the chat, I'm going to put a link to a whole bunch of sine equals cosine questions. So let me get that up. Maybe. There we go. Okay, let me copy and paste this into the chat. So sine questions. Okay, so there's the link for that. What I'll do right now is I'll just grab one of these questions off and we can talk about it. They're very repetitive, unfortunately, because there's only so many different types. But I'll go number 2. It looks like here. All right, so in number 2, it says, all right, I got sine of 2 times angle A equals cosine of 3 times angle A. What's angle A have to be? Well, I'm not going to get freaked out by 2A and 3A. What I'm going to see right away is, hey, you're setting sine and cosine equal to each other. And I know the only time that those two are going to be equal to each other is when their angles are complementary. So I take 2A, I take 3A. Again, I know for a fact those two angles have to add to 90 because that is the only instance when sine and cosine are equal. And then from here, I just solve for A, 5A equal to 90. A is equal to 18 here, I believe. All right, so that's sine and cosine are equal. Boom, right away. I know their angles are complementary.
Pretty much.
Yep, sure. Let's pick another one off. Let's see. I only got 15 of them. Yeah. Okay, so I'll try 13. A little something different. And then I know a couple people hopped on here, so just let me put the link back in of what I'm working from here. You guys that just hopped on, I'm doing some when sine equals cosine questions. And I'm going to put in the chat right now how to get, there you go. That's how you can access this worksheet. And I'm doing number 13 from it right now. All right, so again, I got cosine is equal to sine. Only time those two ratios are going to be equal is if their angles have to add to 90. All right, their angles have to be two acute angles that add to 90. So I could take my 2x, and I know, again, I always say this in class, it's very easy just to set this equal to 55 and go. All right, but again, cosine and sine ratios are only equal if I know their angles add to 90. Their angles are complementary. So instead of setting them equal, I'm going to add them up and set them equal to 90. I get a 30 spot there, I think. And x equals 30. And you can always check your answer. You can take your answer, plug it back in for x, and actually see if the angles add up to 90 or not, to be on the safe side, if you ever want to check your answer. Okay, also I have finding a side, finding an angle, depression, elevation, wherever you guys want to go here.
Could you do some weird word problems? Because I don't feel that comfortable with those. Just say with elevation or depression.
Yeah, I got it. Yep. So here you go. Let me get back to this page. Where'd my trigonometry? There it is. Okay, finding, where was the side one? There it is. All right, so again, this is what I'm going to share with you guys is a whole bunch of problems on finding a side. All right, finding a side using sine, cosine, tangent. So here you go, find a side. And I'm going to go all the way down to the bottom here. For one of those crazy problems, we'll do 13 here because this looks like it has angle of depression in it. All right, so one where we have to draw our own picture here. Ship on the ocean floor detects or ocean surface detects a sunken ship on the ocean floor. All right, so I got a ship on top, a ship on the bottom. I don't need to make this too crazy here. Here you go. There's my one on top. Boom, there's my one on the bottom. Angle of depression of 50. So remember, angle of depression. This ship's angle of depression is from his horizontal line of sight looking down at the ship on the floor. That created a 50-degree angle. And remember, this is outside the triangle because here's my right triangle right now. Okay, so that 50, if its angle of depression is outside your triangle, outside.
Wait, why can't you do a triangle connecting the ship and the...
So this one, like this one right here?
Yeah.
Yeah, that's fine. I just want to make sure you put your values in the right spot though. Okay. So you could do that. That's fine. Let's see. What do I have? The distance between the ship on the surface and the distance between the ship on the floor is 200 meters. And it doesn't say, I don't see the word horizontal distance in there at all. So it's talking right from the ship on top to the ship on the bottom, 200. So it's got to be here. If I put the word horizontal distance in there, then yeah. Okay, we can talk about the bottom leg there, but that's not what it's talking about. How far above the ocean floor to the nearest meter is the ship on the surface? So here's my floor down here. There's the ship on the surface. They're asking me for this length right here. So a lot went into that problem as far as the diagram. Now we got to solve it. I can't use the 50, guys. I need a little help here. The 50 where it is outside my right triangle is not going to help me. I need an angle inside. So there's one or two things we could do. What's one thing I could do with that 50?
All interior angle.
Say that one more time, Maeve.
All interior angle.
Yep, alternate interior angles, right? So if that's 50, if you want, put the 50 down here where its alternate interior angle would be. Another option, if you want, is adjacent to the 50 here would be a complementary angle. So I could use 40 if I wanted to here. All right, so just make sure you got a plan going into tomorrow if you got an angle of depression problem. All right, I'm just going to keep the 50 where it was. All right, perfect. I got the opposite side I'm trying to find. 200's the hypotenuse. And then I just got to say to myself, what do I use with O and H? I got to use sine. Sine of 50 equals x over 200. Cross multiply and rounding to the nearest meter. Whatever that would come out to be there. And then while I got you guys here, I mentioned this to the people that came in yesterday for a review. It has nothing to do with sine, cosine, tangent, but I'm nervous And I've seen in the past a lot of kids get silly points off because they don't read the rounding directions. So tomorrow you're going to get nearest whole number like this problem. I'm going to give you nearest tenth. I'm also going to give you nearest hundredth tomorrow to round your answer to. All right, so just keep in mind, 1, read the question carefully, and 2, make sure you round to what you have to round to. So hundredth, we'd be expecting 2 numbers after the decimal, tenth, 1 number after the decimal. So please watch out for that, because that's a point every time you round incorrectly. All right, so I just wanted to give people a heads up on that. Make sure you know where to round, because there's not going to be any simplest radical form on here. You don't have to worry about that on this one, just the rounding.
Can we do some SOHCAHTOA problems, stuff with the word problem?
SOHCAHTOA, what was this one?
Well, this is easy.
Sine. It was a sine. All right, well, let me just at least, because I was going to give you guys 3 worksheets here. So let me give you the other one, which is find an angle now. And so here is find an angle for anybody who's interested. All right, here you go. I did this one yesterday. Number 11 is pretty diesel. Pretty beefy. Swole. That's probably the word you kids use nowadays on the streets. Oh, shoot. Number 11 from that link I just sent you. All right, let's do this. Got a lot going on here. It's asking me to find angle theta. And again, theta is just like a variable. I could put an X in there. I could put a Y in there. Find that angle right there where theta is. All right, where that symbol is. Find the measure of that angle. But we have a problem. Right away, we have a problem. If you look at the triangle where that angle is contained in, look at the triangle. I got a problem with that triangle. Nobody's doing sine, cosine, tangent on this triangle. Why not?
It's not right.
Yeah, it's not a right triangle. Don't even think about it. You know, oh, I could do 60's opposite. No. 60's opposite, but you can't use sine or tangent because it's not a right triangle. Sine, cosine, tangent can only be used if I'm involved with a right triangle. So I need another method to find that angle right now. I need something, and then they should have put it in here, but this is a right angle. Those two are perpendicular. So we have any suggestions here, because using that triangle is not going to cut it. But I still need to find the angle, and I can find the angle.
You find the bigger angle, then you find the smaller angle, then you subtract.
Okay, so here's what's going to happen, everyone. I have a small right triangle at the bottom that has legs 12 and 75. We see that? I can find this angle using sine, cosine, tangent. I'll call that y. And then there's a bigger right triangle that's got 60 and 12 as one leg and 75 as the other leg. And I can find this angle right here. I'll call that x. And then I could take x minus y and see what I'm left over with, angle theta, the one I'm looking for. All right, so that's how I'm going to have to go about this one. 2 different ratios right now. One for the big triangle and one for the small one. So let's go to the small one real quick. I'm going to find y now. So let's see, what are the 12 and the 75 from y? Looks like opposite and adjacent. 12 is opposite. 5 is adjacent. So I'm going to use TOA, tangent. Tangent of y equals opposite 12 over adjacent 75. We're about to find an angle. You can cross multiply, but you're going to get lost. Don't try to cross multiply. You know, when we find an angle in a right triangle using sine, cosine, tangent, I got to use the inverse. Grab my calculator. All right, so for this one, I'm going to do y equals inverse tangent 12 over 75. And this is also a great problem because now I can talk about this. We're not done with the problem. Once I type that into my calculator, we're not done with the problem. What am I trying to tell you guys? Keep the full calculator display. Do not round anything. You're right in the middle of the problem. So second tangent, 12 over 75, 9.090276921. Don't round it. It may throw off your final answer. Now let's find x, the one in the big right triangle. Now I can do tangent again. Tangent of x. Opposite side now is 12 plus 60. 72. And the adjacent side still remains 75. Again, inverse tangent. Let's see, inverse tangent 72 over 75. There you go. And then our plan from the beginning was take both angles and subtract them from each other. So I don't have to rewrite it, this one minus this one. And then I can round. To, what was it, nearest 10th? There you go. Here's nearest 10th now, 34.7 degrees. All right, so a lot of good stuff on that one. A lot of good stuff. How we doing? Others, anything else you guys want to talk about here?
Mr. Kalina?
Yes, Peter.
Do you go over question 10 yet?
Question 10 from what?
The same packet.
The angles one?
Yes.
No, I did not, and I'm not going to go over that one.
Okay.
All right, I have my own reasoning for not going over that one. Sorry. Others that you guys want to, I know some people are just hopping on, which is fine. I just want to make sure you guys have the same thing I've handed everyone else. So this one right here, guys, is finding an angle. What I just shared in the chat, finding an angle. Find an angle, find a side, sine equals cosine. Anything else you guys want to talk about?
Can we do an elevation one?
Elevation one, sure. I just got to find one. Here you go. 16 on the same one we're working on. That says find the elevation. Okay, so I got a man standing on level ground 100 feet away from the base of a pretty tall building. All right. If you guys want to get fancy with your artwork, go ahead. Let's see, it's a 350-foot tall building. He is standing 1,000 feet away from it. All right, find to the nearest degree the measure of the angle of elevation to the top of the building from the point on the ground. Okay, so this one here is a little bit different than from what we're used to. What we're used to is, hey, we usually go from, if we're dealing with a person, his eye level up to the object here, but it says find the angle of elevation to the top of the building from the point on the ground where he's standing. So that's where our triangle is already, on the ground. So all it's asking for is this right here, our angle of elevation. All right, again, sometimes it is from his eye level up, but it says, notice what it says. See the difference, guys? The start of the angle of elevation is on the ground where he's standing. All right, so if I wanted to move my guy up a little bit, here you go. Okay, from where he's standing on the ground, not his eye level here. All right, so there's the angle of elevation I'm looking for. Let's see, 350 is opposite. 1,000 is adjacent. Tangent. Opposite over adjacent. And then just like the previous problem, anytime you're finding an angle, you want to use the inverse of whatever ratio you're using. And then I didn't even take a look. What were the rounding directions? Nearest degree here, nearest degree. I'm getting 19 degrees on my end here. Good. Any other things we want to talk about? You guys that hopped on, I talked at the beginning, it has nothing to do with sine, cosine, or tangent, but just pay attention to rounding directions tomorrow, please. Pay attention to that, because I may ask nearest whole number, I may ask nearest tenth, nearest hundredth, and those points add up quickly. All right, so please watch out for what you're asked to round to. There's not going to be any simplest radical form on there. It's just strictly rounding tomorrow. You got to watch out for.
Will you pick points out because we forgot to write units?
No, I will not. No, I'm not going to be that hardcore. But it will be 1 point off if you round incorrectly. Like I had somebody today who took it, who the directions were round to the nearest hundredth. They left it as the nearest tenth. Okay, so there's a point off.
Well, we have to know the properties of a rhombus.
There are no quadrilateral questions on there. I would have warned you guys, so no, nope.
Okay.
Yep, we just have to worry about good old right triangles tomorrow, and when sine equals cosine. And again, also, I said this in class, but you may have to use Pythagorean theorem. That's always an option when you're dealing with right triangles. So, anything else you guys want to talk about? And I maybe the last thing, because I've seen more and more of this, unfortunately, is like in this problem I have up here, the sunken ship one we did. Make sure whatever degree measure it is gets actually into your diagram. Because I've seen, in this case, 50. Maybe, bad handwriting or whatever, you're going too fast. All of a sudden it becomes 58. Okay, because of a little mark. So just watch out for that tomorrow, especially when you're labeling a diagram or doing your own diagram. Make sure the actual numbers from the problem get into your diagram. I'm just starting to see more and more of that. And everything else is beautiful and correct, except you used the wrong degree measure.
Are you grading our pictures?
Oh, if I did that, Peter, people would have no shot at passing. No, I'm not. No. Heck, I wouldn't even pass. Look at these things. If you just want to draw yourself a right triangle, just draw yourself a right triangle.
You might have already talked about this.
Nope,
but
go ahead, Lynn.
Can you review like the idea where sine equals cosine?
Yep, here you go. Let me share the link that you can get a bunch of questions from. Here you go. This is sine equals cosine coming at you in the chat. All right, I'll do a different one than what I did at the beginning. They're pretty repetitive. I'll do number 4, I guess. All right, so here we go. Value of x, sine of 60 equals cosine of x plus 10. I know it's very, very tempting just to set them equal to each other because you see the equal sign. Heck, I'll just set them equal. But again, if we are going to set sine and cosine ratios equal to each other, that means one and only one thing. These two right here add to 90. Those two angles have to be complementary. So I take my 60-degree angle and my x plus 10 angle, add them together and say, hey, I know those two have to add to 90 because that's the only time sine and cosine are equal. So I got x plus 70 equals 90, x equals 20. And I mentioned before, if you want to see if you're correct or not, take 20, plug it back in for x, and your angles should add up to 90, or even better, go to your calculator. Is the sine of 60 the same as the cosine of, let's see, if I plugged in 20, 30? And they should be. So anytime you see sine and cosine equal to each other, those angles are complementary. Anything else, guys? Andrea.
For conversion, is it just the in inches and then miles and feet?
I would expect you to know inches and feet, but anything else I would provide on a problem for you.
Okay.
Yeah, I'm not going to have you be responsible for anything other than 12 inches in a foot, but other than that, I'll provide it if it's needed. Yep, that's another good point Elizabeth brought up. Why you need to read carefully. Is your diagram in the same units as what I'm asking your answer to be? Nothing else, guys? Okay, well, you guys know the deal. You can always reach out to me tonight if there's a problem you want to see done. I could definitely do it real quick on my Chromebook and send you guys the screenshot of it, or just questions in general. Don't hesitate to reach out to me. All right, you guys have a good night, behave, and I'll see you tomorrow here or virtually for the quiz. Good luck.
Thank you.
You're welcome, guys. Thank you for coming.